This is a quick demo to showcase Hedvig's capability of providing block, file, and object storage using the same cluster. For this setup, we'll use VMware as the hypervisor, create NFS data store from Hedvig, then we'll run a VM using Hedvig's NFS data store. For block storage, we'll create an iSCSI volume and consume this iSCSI volume as a raw disk in our newly created virtual machine. For object storage, we'll use S3 browser to create buckets and simple AWS CLI to upload multiple objects. And in the end, I'll also show you Hedvig's OpenStack Cinder integration. Let's run the demo. This Hedvig cluster is a dual data center cluster with 6 storage nodes and 3 storage proxies. One of the storage proxy will be used as iSCSI target as well as NFS server. Second storage proxy will be used as S3 server, and the third proxy will also be used as NFS server. There are 6 storage nodes in this cluster, so 3 of the storage nodes are in first data center and rest 3 storage nodes are in the second data center. First of all, we'll create an NFS volume from Hedvig UI with replication policy set as data center aware and every other property set as default value. We'll use this NFS volume to create NFS data store from VMware. So after creating the volume, we'll add this as an export to one of the storage proxies, which will be used while creating NFS data store from VMware. As you can see on the screen, we are using our proxy as a server name and the NFS volume that we created from Hedvig UI as the data stored name. We'll clone an existing Windows virtual machine and use this newly created NFS data store for its storing virtual machine data. Now we'll move on to the block storage. First, we'll create a new block volume from Hedvig in similar fashion as we created NFS volume and give our newly cloned VM access to this block volume using the IP of the virtual machine. We can use iSCSI initiator with Hedvig storage proxy as the target to discover this volume inside our virtual machine. Once this volume is discovered, we can simply create NTFS file system on it and use it as a locally attached volume. Now we'll move on to the object store part of this demo. We'll create 2 buckets with 1 folder inside each bucket using S3 browser and make sure corresponding volumes are created in the Hedvig cluster as well. For the final part of the demo, we'll move on to a simple OpenStack installation where I've already installed Hedvig's Cinder volume driver, as you can see on the screen. We'll use this driver to create a new volume and we'll use a basic OS image to be stored inside this volume. Once the volume is created, we can also confirm using Hedvig UI that it exists in Hedvig cluster as well. We'll create one more volume using Hedvig's Cinder driver type and attach it to our newly created virtual machine. We can use command line to log in inside our virtual machine and make sure an additional volume also exists inside the virtual machine. This concludes our private cloud demo.